So students, welcome to lecture number 5 in the series of design of concrete structures. Earlier up to lecture number 4, we have discussed some properties of concrete which are most relevant in the design of concrete structures. Then we have discussed limit state methodology of the design, that means information regarding two type of methods, working stress method as well as limit state method. So in limit state method we have discussed that there are two type of limit states. Number one is limit state of collapse and second one is limit state of serviceability. So I hope that you are all aware regarding the basic concept which we have discussed, and you have watched all the 4 lectures carefully, and I'm happy that many of you are directly asking the questions in the comment section, and as per the time availability with me, I'm trying my best to reply your queries. So today in lecture number 5, let us discuss what we are going to discuss today. So first of all, some information regarding limit state design method as per IS 456 2000. We will also discuss regarding the characteristics, strength as well as loads which any building is going to encounter. So what are the various materials which are to be used in case of RCC structures, and what are the various type of loads which we are going to consider in the design as well as analysis of the RCC structure. Then we will go through the various partial safety factors which are to be used in case of limit design methodology as per the recommendation of IS 456. Then design strength as well as design loads which are to be taken in the calculations for the design of the RCC structures. So let us continue. So limit state method of design of RCC structure. Today's topic is loads which we are going to be considered in design calculation when any RCC structure member you are going to design. So let us go through the details. Now, what are the loads which we are going to consider? So first of all, the determination of various type of loads which a structure may experience during lifetime, as well as combination of loads which are required to be decided based on the probability occurrence in the light of guidelines suggested in standard. So what is the purpose of or what it indicates? That whenever you are going to design a structure, that means you will be going to do some calculations based on which you will be able to just work out the cross section as well as the material requirement, type of material, etc. So all the information we are going to enlist in case of design calculations as well as the drawings which will be the supporting the design. Now various type of loads which any structure will be expected to be experiencing during its lifetime. So that means we are not aware, or we can't say exactly what will be the load which a structure will be going to encounter. So that means based on the probability of occurrence, we will be going through first of all assuming the various type of loads based on the geographical region where the building is to be located and all the other parameters which we may later on take into consideration. So there may be various type of loads. So during design, we have to take into consideration combination of loads. Later on, you will be able to understand that what is the meaning of combination of loads. and all these loads are based on the probability of occurrence, and this probability of this information we will be taking care with the help of the IS guidelines, that means Indian Standard Codes. The probability that a specific load will be exceeded during the life of a structure usually depend on the period of exposure, that means the life of the structure, whether that specific load, any type of load, can exceed its limits which we have taken into consideration while designing of the structure. It depends on the exposure of the structure, how much lifetime you are going to be expecting for a particular structure when you are going to design, as well as the magnitude of the design load. Then load need to be considered in design calculation. They depend upon the location as well as type of the structure, such as when you are going to consider wind load, when you will be taking consideration of the wind load in the design calculation, that depends on whether the structure is located in a such type of area or such type of zone where wind load are expected to be predominant. As well as similarly, we can talk about the earthquake load. Whether earthquake load is to be considered, that depends on the geographical region of the area where you are going to be constructing the building or any structure which you are going to design. So what load you have to take into consideration, that depends on the various factors. That means what is the type of the structure. Suppose there is a tower type of structure, that means having a greater height, then definitely wind load may be affecting it. But if you are just going to construct a building just as a residential, maybe single story, double story, you may ignore the wind load criteria depending upon the location also. Now, in the limit state of design method, that means loads. So first of all, we will be discussing what is the dead load. So now let us go through the information. Dead load is the load which can be considered as fixed in magnitude and position, and that type of load will be termed as dead load. And this dead load you can assume based on the assumed dimension. That means when you are going to design any, suppose a RCC beam, so first of all you are not having information regarding the cross-section dimensions of the beam. So first of all, in the design methodology, in design steps, you will be going to assume some value for the cross-section dimensions of the beam. So according to the assumed dimensions, you may be working out that what will be the self weight of that particular beam or that section. So accordingly, that load which you consider that it is a fixed in magnitude and position, you will be considering or you will be terming it as a dead load, and its calculation can be, as I told, will be depending on the dimensions which you have assumed as well as the material of the structure which you are going to under design, whether it is concrete, whether it is steel or any other type of material. So based on the unit weight of that material and dimensions of that material, you will be able to work out an assumption for the dead load. Now here we will be taking help of IS 875 part 1, that is Code of Practice for Design Loads other than earthquake for building and structures. So that means if you are going to design any building or structure and you are not considering in your calculation the earthquake load, that means the building is not in any earthquake zone where earthquake is frequently occurring. So for that you can refer, for your calculations, the guideline mentioned in IS 875 part 1. So But IS 875 part 1, it is for dead load, and you can collect the information regarding unit weight of building material and stored material. Now this is just a snapshot from the IS 875 part 1, just to illustrate what actually information, how actually we can get the information from the IS code. So this is IS 875 part 1 1987 version, just for illustration purpose. So you can go through the table number 1, and the table number will give the information regarding unit weight of building materials. And now you see here, if your building material is a cement concrete, it may be pre-stressed or it may be reinforced. So that means when you are going to be using cement concrete as the material, then unit weight will be taken as 2400 kg per meter cube. So by this information, that means better you are taking the unit kilonewton, then it will be 23.5. But in normally we will be taking unit as kg per meter cube, then you can take 2400 as kg per meter cube unit weight of the cement concrete. Accordingly, other type of information is available in this table number 1. I have just taken little bit information just for the illustration purpose. Now, second type of load which are prominent in case of structures or buildings which we are going to be designed later on, that is imposed load. Now, what are imposed load? They are also gravity loads other than dead loads, which may include items such as occupancy of people. That means later on the structure will be occupied by people. So their load, which is movable load, can be considered as imposed load. Earlier it was called as a live load. So any equipment which you can consider that it can be movable, not fixed. Furniture within the building, movable material which is stored, such as books, machinery, whatever be. So imposed load means it is a live load, and that load can be removed. That means it is a movable, it is not a fixed type of load. So that type of load will be termed as imposed load. Earlier it was already told that it was termed as live load. Now there are different type of buildings. So these type of imposed load may be different for different type of building as per their use or as per their purpose for which they are built. Second point which we can take into consideration, they are generally considered as static load for convenience of calculation. There may be a little bit dynamic effect of imposed load also, but for calculation, for the simplicity of the calculation, we are not going to take into consideration that dynamic behavior. So you can consider while doing the design calculations. So dead load as well as imposed load, they both are taken as static loads. Indian Standard Code provide uniformly distributed loads as well as concentrated load for various occupational categories. So you can refer the Indian Standard Codes for various type of category of loads. The distributed and concentrated imposed load shall be considered separately, and the design carried out for the most adverse conditions. So here you will be come across the term combination of load later on. That means when you are going to design a structure, you have to take the combination of load and you have to follow that combination of load which is going to offer most adverse condition, so that our structure should be designed for adverse possible conditions which may happen during its lifetime. Now refer here, this is IS 875 part 2. Now this code gives you the guideline, and the title of the code is Code of Practice for Design Loads Other than Earthquake for Building and Structures. So in this IS 875 part 2, you can refer table number 1, and table number 1 is for imposed floor loads for different type of occupancies. Now see here, you can refer here, they have enlisted some listed the occupancy types. Now if there is a residential type of building, it may be a commercial type of building. So accordingly UDL as well as concentrated load value you can take for your design calculation, as they have mentioned just a snapshot, a little bit information. Dwelling houses, all room and kitchens, you can take UDL as 2 kilonewton per meter square as well as 1.8 kilonewton for concentrated load. Now you can see here unit system you have to take because it is concentrated load, so it is unit will be kilonewton, and when there is UDL, uniformly distributed load, then a unit will be kilonewton per meter square. So IS 875 part 1 we refer for the dead loads, and IS 875 part 2 we will be referring for the imposed type of loads for building and structure. Here you have to be clear that no earthquake consideration will be taken. For earthquake type of loads you have to refer a special code, that is IS 1893, and maybe during our design theory which we will be going through later on, earthquake type of load may not be considered. Now let us briefly discuss about the combination of the loads. So as per IS 456 recommendations, code has given these three type of combination of loads: dead load plus imposed load. That means whatever be the dead load and imposed load, first of all you will be adding them and you will be working out some quantity. Then second will be dead load plus wind load or earthquake load. So it is very much sure from the past experience that whenever there is a high wind velocity, wind is blowing with a high velocity, then possibility of earthquake is negligible. So that means they both type of loads need not to be considered simultaneously. Either you can consider wind load or you can consider earthquake load. Third type of combination of load is dead load plus imposed load and plus wind load. So when you are going to do the calculation for various type of combination, and whatever be the adverse type of load, or you can say highest value of the load, that will be considered for the design purpose. Now we are going to discuss some codal recommendations in listed in case of a limit state method of design, and you can refer clause number 35. That section is totally devoted to limit state method in IS 456. Now some of the terms which we are going to use in limit state method. So let us go through these terms. Now very first term which we are going to use, and that is clearly mentioned in clause number 36.1 of IS 456, that is the characteristic strength for material. As we have gone in detail regarding the characteristic strength of concrete, so here we are using two types of material, and the concrete as well as steel. So what code is mentioning or code is suggesting, that can be referred in clause number 36.1, and let us go through just a revise characteristic strength for material. Now when we are talking about concrete, so the characteristic strength of concrete is the strength of concrete below which not more than 5% of test result are expected to fall. We have gone through this information in earlier lecture 1 or lecture 2. If you still have any doubt, you can refer previous lectures, and you can refer table number 2. Now in IS 456 table number 2, which can be referred for different grade of concrete. So that means according to the different grade of concrete, what is the characteristic strength, that is clearly mentioned in table number 2. Second material which we are going to use in our CC structure, that is steel reinforcement. So the characteristics value shall be assumed here as the minimum yield stress or 0.2% of proof stress, which is specified in relevant Indian standard specification. So you are, I think you are well aware regarding the concrete, because all these information we have discussed in the preliminary lectures, and regarding the steel reinforcement, that already has been discussed in strength of material. Now let us go through this table number 3, and this code is IS 1786 2008 version. So what table 3 give us information regarding the mechanical property of high strength deformed bars and wires, which we are going to use in case of design of RCC structure. Earlier there was a mild type of steel, that is mild steel. Nowadays we are not using mild steel in case of RCC structures. Now table number 3 give us information regarding the high strength deformed bars, and this is the grade of the steel which from which these reinforcement bars are manufactured. It may be Fe 415, 415D, 500, 500D, 550, 550D, and 600. Now, this 600 has been included in the latest revision in this code. Now, 0.2% of proof stress or yield stress, this is the minimum value. So, mechanical strength, that means the yield strength which we will be taking. If you are taking Fe415 steel into design, then you will be taking its yield strength, minimum yield strength, that is 415 MPa. So accordingly there are various type of grades of steel, and accordingly you can take the value of the yield strength of that steel for your design calculation purpose. Another important thing which you have to take into account, that now the nominal size of the reinforcement bars which are available as per the code. Now these are the 4 mm, 5 mm. These are the diameter of the bars which you are going to take into consideration while designing 8 mm, 10 mm, 12 mm. Earlier there was 22 mm dia bar also, but now they have removed in the latest revision in the code. So I am not going into detail what are the various revision. So these nominal diameter bars are available in the market, or they are manufactured as per the codal guidelines. So whenever you are going to design, you can assume any type of, or you can take into consideration any type of any diameter of the bars from these values which are given here as per their requirement and as per their application, which you will be later on understand more effectively. Now another is earlier we in the previous slide we have gone through the characteristics strength. Now we are focusing on characteristic loads. So for this information is available in clause number 36.2. So let us briefly discuss this. The characteristics load is defined as the load that has 95% probability of not being exceeded during the life of the structure. So what we are considering here as per the definition, that means characteristic load will be that load which has 95% probability. That means there is the probability or possibility, 95% of the possibility that it will not exceed during its life of the structure. So that load you will be taken into consideration in the calculation purpose. That will be the termed as a characteristic load. Now code is saying that in case of or in the absence of any statistical data regarding load, nominal value specified for dead load, live load, and wind load can be taken from these code IS 875 part 1, part 2, and part 3. And the value of seismic load, that means when you are going to consider earthquake load in case of design, then you can refer IS 1893 2002. So till this we have discussed what are the characteristic strength and what is characteristic load. Now we are going to focus on design strength. Now Now we have switched over from characteristic strength to design strength and characteristic load to design load. And for this, we can refer clause number 36.3 of IS 456. The design strength of concrete or reinforcing steel, that means design strength of the material, is obtained by dividing the characteristic strength, which we have already discussed, by the appropriate partial safety factor. Earlier in the introduction part of limit state method, you may remember that we have discussed here that instead of a working stress method where we were using factor of safety, in limit state method we are using partial safety factor. And this partial safety factor depends on various factors which later on we will be going to discuss. So when you have to calculate, you have to find out the design strength of any material, then what you have to do, you have to just divide the characteristic strength, take the value of characteristic strength of that material, and by appropriate partial safety factor, by applying various consideration which we will discuss in the coming lectures. Now, design strength and design load. First of all, partial safety factor in limit state method, and symbolically we will write it as gamma. Now, first of all, partial safety factor for material. So you may be able to understand that here we are going to take partial safety factor different for material as well as for load. So first of all, this is gamma m. Gamma is partial safety factor and m is used to indicate the material. So gamma m is partial safety factor for material. And for concrete, as mentioned in Indian Standard Code, we will be taking partial safety factor for concrete 1.5, that is gamma c is equal to 1.5, and partial safety factor for steel will be taken as 1.15. Gamma s is 1.15. So you can see here we have taken partial safety factor for concrete somewhat higher than partial safety factor for steel. So here why we are taking this, you can refer any standard material, and this will be the first question for all of you. So you can just get the information and write in the comment section. You can refer clause number 36.4.2 of IS 456 for partial safety factor information regarding the material. Next is partial safety factor for loads. Here we are using symbol gamma F. Here we were using symbol gamma M. Gamma M for material and gamma F for loads. So gamma F, that is partial safety factor for load. It is the partial safety factor value for various combination of loads. Now here you can see here that we are using various type of combination of loads which we have discussed in the previous section for ultimate limit state and for serviceability limit state. So that means you have to take the partial safety factor for loads different for different type of combination of loads and different value for ultimate limit state as well as serviceability limit state. And information is available in table number 18 and clause number 36.4.1. Now this is the table number 18 which we have taken from IS 456. So value of partial safety factor gamma F for various type of loads. As we have discussed here that various type of load combination we are going to discuss. These are the combination of loads. So here as the combination of load change, partial safety factor will change. So various type of combination of loads: dead load plus imposed load, dead load plus wind load, dead load plus imposed load plus wind load. Now see here in note it is mentioned while considering earthquake effect, substitute EL for WL. So that means either take EL or take WL. Now in second column you can see that these are the value of partial safety factor for limit state of collapse. which we have termed as ultimate limit state. So dead load, imposed load. If you take into consideration first combination of loads, that is dead load plus imposed load, then you have to take this value. That means for dead load, partial safety factor gamma F is 1.5, and for imposed load it is also 1.5. And if we are taking into consideration wind load, then partial safety factor we will take 1.0. Now, if you are going to discuss, take the value for limit state of serviceability. So this partial safety factor for dead load, which was 1.5 here, you will take it as 1 for this type of combination. And imposed load 1, and wind load it is not specified in the code. So accordingly, what are the various type of combination of loads you are taking into consideration? Accordingly, partial safety factor are mentioned. Now here another question which I want to ask to all of you, so that you can just grill yourself and you can refer some standard material. Now here if I say this is A type of combination of load, and this is B type of combination load, and this is C type of combination of load, you can see here we have taken different values for partial safety factor for dead load in case of first combination, second combination, and third combination. Why we have taken so much variation in the, or in other language we can say why the partial safety factor is varying from 1.5 to 0.9 or 1.5 to 1.2. So why it is decreasing when you have changed the combination of load, type of combination of load. So this question is for all of you who are going to watch this video, and you must go through some literature or some standard book, and just write your in the comment section your reply. And similarly for serviceability limit, you can consider also. And third question which I want to ask you, suppose we are taking this first combination of dead load plus imposed load. In limit state of collapse, we have taken partial safety factor 1.5 for dead load. But in limit state of serviceability, we are taking the value 1. Why this variation in the partial safety factor is taken into consideration? That means why lesser partial safety factor is taken in case of limit state of serviceability, and why higher value is taken in case of limit state of collapse. So I am expecting all of you go through the lecture carefully, as well as the 3 or 4 questions which I have asked. You must reply uh, in the comment section of the YouTube video, which I am going to upload later on. Now limit state method of design here, some more information, that is design strength and design load, how to do the calculation for it. So as already discussed, design strength of concrete or steel can be calculated by, or can be evaluated by dividing characteristic strength by appropriate partial safety factor. So when you are going to calculate or evaluate the design strength of material, it may be concrete or it may be steel. So we will be going to use this formula, which is available in IS 456 in clause number 36.3 onward. So here F is the characteristic strength of the material, and gamma M, as we have discussed, partial safety factor, which is appropriate based on the material and the limit state being considered. I think you are able to understand that what is the meaning of appropriate to the material and limit state to be considered. It indicates that limit state, whether you are taking limit state of collapse into consideration or a limit state of serviceability. Accordingly, you have to pick the value gamma M. So what we are doing here, we are just taking in the design calculation. That means if you are here material is, suppose it is concrete, then design calculation, we are taking the design strength of that concrete is lesser than its actual characteristic strength. So we are applying partial safety factor here. In earlier lecture, I have explained you that what is the use of partial safety factor, why we are taking partial safety factor. So here question number 4 comes out to be what is the role of partial safety factor in case of material we are taking? That means what is the significance or why we are taking partial safety factor of material into consideration. So that answer I am expecting from all of you, those who are listening the lecture, they should write in the comment section. Now design load, here we have taken capital F for the symbolic purpose. Capital F is for the load and D for the design. Here F, which is a characteristic load, is multiplied by partial safety factor appropriate to the nature of loading and the limit state which you are going to be considering. So here we are multiplying the design load, but in case of design strength, we were dividing the characteristic strength by partial safety factor. So that means we are taking strength at a lower side, but design load as at a higher side. So here that means we are again uh, assuring the, you can say assuring the that there should not be any type of a failure in the design. That means when you are going to design a structure, you are doing the calculation, you are taking strength at lower end but load at higher end, so possibility of failure will be automatically reduced. Thank you.